Okay, I think the recording has started. So once more, welcome everyone to the class. So I'll start by sharing my screen and we'll be going back to what I said would be the source of truth for us while going through this process of writing Soroban smart contracts and deploying it. And the source of truth we made mention of is the Stellar official documentation. And that is in fact what we followed through while we started writing this smart contract. So what we did in our last class was basically seeing the components of a smart contract. And in that case, this is what we did. We basically saw how the Soroban SDK was imported. We discussed what the contract itself is, the entry points to the contract, which identifies the contract name itself. In EVM for Solidity, you would name it as contract, then you have the name before you start open the parentheses and all of that. So in this case, what you will do instead of that, as we made mention from yesterday's class, is to create a public struct and then you have the contract name. So how do we know, even if we have 20 structs here that is serving as the data storage, the data structure for the storage, the important thing is you having this procedural macro contract on top of the structure you are using or identifying as the main entry point to your contract. Another thing that shows that this LO contract is what you are using as the major entry points to the contract, as we made mention, is implementing it. So the moment you implement it, all of the methods inside of it would be the functions associated with the contract. So we were able to look at this simple function, LO, and this LO word function. And from there, from yesterday's class, we're also able to look at testing when it comes to Soroban smart contract. So all of what we saw yesterday was just a simple spin-up from scaffolding a new project. So the moment you scaffold a new project, what you get from scaffolding that project is what we can see directly on our screen. Although we added this ourselves, but it's what you basically see, just this LO. And then a test also comes with it. Why, you may ask, why does this come with it? One important reason is to help guide so you don't start writing everything from scratch. But it doesn't mean you can basically write everything from scratch. But you have to basically modify everything that is being scaffolded for you for it to suit your own use case. So I don't know if anyone has a question from our last class before I proceed into today's class. So if there are any questions coming from the last class, then you can do well to ask me now before I proceed to today's class. But if there are no questions, I can get a thumbs up, then I can basically move forward to having what we have in store for today. So are there any questions? Okay, yeah.
Yeah, so you talked about that struct, that whenever you want to write a struct, that you should put that contract there, right? Doesn't mean that if you have like multiple structs, you always put that contract in the multiple struct. Like any
The answer to that,
at all.
the answer to that is no. And that's what I
Okay.
was basically trying to explain. I was explaining that the entry points to this contract is LO contract. It's literally LO contract. You understand? That's the name of this contract. You get. So when you have other structs that are serving as a data structure for the storage, all of these other structs would not have this LO contract. Instead, they would have a different procedural macro that we are going to see. In today's class, we might not see that procedural macro, but in upcoming class, because today's class, what we'll be building is literally a simple project that does a simple increment. So we are going to test it, we are going to deploy it, and then we are going to interact with it. All of these things we are going to do basically with the use of the Stellar documentation, just to show how easy it is as a developer to go through the documentation and for you to understand what you are working with the documentation. It's also good for you to have reference as to why working. You can easily have something to go back with. And that's exactly why I did not prepare a slide for this intentionally. Rather, I wanted us to have hands-on experience with working with documentation, understanding when there's a bug and how to go back to it. So does that answer your question, Coxie?
Yes, it does.
Okay, thank you very much. So going back to what we have discussed yesterday, we were able to scaffold the project and talk about the different components or the different parts that make up a Soroban smart contract. We also spoke about the testing. So today we'll be scaffolding a new project, and that project, let me close this so we don't have too many. So that project, we would name it, yeah. So I'll just create something from here, and we are going to scaffold the new project. To scaffold the new project, let's go back and see how to scaffold the new project. Can you see? Documentation. To scaffold the new project, you literally need to type out Stellar contract in it, then the name of the project. How important documentation is. So we go back and we say Stellar in it, then the name of the project. Stellar contract in it. Yeah, I knew I made a mistake. Say Stellar contract in it. Then what do we name our project? We name it increment or incremental. Let's name it incremental. Incremental. And then we create it. Now we've created it. Let's see. And then let's seed into it. And yeah. So let's see. Okay, our project has been created. So let's open it up. So we are going to close this since we no longer need it. And we'll make this bigger and increase the size just to make it clear. So just like I've made mention of, what we would have here is obviously the LO contract. And the LO contract is what comes with the contract whenever you just, scaffold a new contract. And so that's basically what comes with the contract. Now you will notice that my Rust analyzer is loading and this is still fetching metadata. And that's exactly why you will notice that all of these are not having the color they are meant to have, unlike the contract I have just closed. So it's going to keep loading. My internet connection is not as strong as it used to be. So for that reason, we would wait a little bit for it to load. So, okay, so we can see. So now for today, the first thing we want to do is we want to create our incremental contracts. And to do that, as I've always made mention of, when you want to do something or create your application, the first thing you have to do is to think, what are the necessary things that would be inside of my application contract? So the first thing is we want to think of the storage. What will the storage look like? Just to be clear that, or to be sure that everyone is still with me, I would come and check the meeting because my internet connection is not so strong, like I've made mention of. So I think it's not showing. Can everyone hear me?
Yes, sir.
Okay. Yeah.
You can still see my screen, right?
Yeah.
Okay. What?
Yes.
Okay, great. So the first thing we are going to think about for what we are working on is the storage. What exactly is our storage? We said we want to create an incremental. What's the incremental contract going to do? It's just a simple contract that is going to keep incrementing a number that is being added up to it. So first of all, we need our storage. What would our storage look like? For that, we want to create a data key for our storage. And for that, we are going to create a simple data key and we name it counter. Counter. And for this data storage, we use symbol. And for that, we will say symbol macro, and then we add counter in front of it. Inside it, I mean counter. So this is going to be our data key. This counter is going to be our data key to our
Can anybody hear me?
Yeah.
Oh, okay. That's fine. Answer.
I think I disconnected.
Yes.
Did I leave the meeting?
Yes.
Oh no. So, oh no, my network, my internet has been really bad of recent. So, what I'll do is I'll switch off my video just to see if it gets better. Okay. So, you can see my screen right now, right?
Yes.
Okay. So, where did you stop hearing me, please? I'm so sorry for the internet connection issue.
Can I see your screen back? I can't remember. I think it's one you're talking about, the vector aspect.
The struct.
No, the vector you were trying to implement.
Okay. This struct I was trying to implement. Okay, so you heard when I made mention of we changing the LO contract name to incremental contract, right?
Yeah.
Okay, so like I made mention of, the incremental contract is what then would be implemented. So the incremental contract is what would be implemented. And so inside it, we do not need all of this. So our contract is now set up for whatever we want to do. So we are also going to go to the tests. Let's clean up the test because we do not want to have errors while we are working. So we have our incremental contract set up and ready for us to implement our function. So the first thing we want to create, the first function is we want to create an increment function, an increment counter that counts by adding 1. So, okay, can you see we had an error here? This is meant to be symbol short. Okay, so we want to have an increment function that counts by adding 1. So to do this, we'll create our function fn and create increment. And what would be inside our increment? First, we have our ENV, which we made mention is where all environmental variable is, where you have access to the storage, where you can basically get even the account of a user. So we will have that. And since we are not adding anything to it, one thing we want to do then is we want to return whatever we counted. So U32, we're using U32 for our counting. And so the first thing we want to do is we want to get the storage. So we say let's mute. We are mutating the storage. So we name it counter, or let's name it count. It's a U32. Then we say env.storage. Just to be sure that my internet is not messing up. Okay. So we say env.storage. Okay. This is Soroban, and it is a framework written with Rust. So we say evm.storage.instance .get, and then we add what we are trying to get. What we are trying to get is counter. Then we say dot unwrap or 0. Okay. So see where we started for ENV, not EVM. Okay. So why are we having this error? That's because we have not yet returned our U32. So I made mention from previous class that we can use the to-do macro just to take out the error if you are like me that do not like seeing error in your code. So the next thing we want to do is our main implementation is to add to this count. So we are going to add to it. So we say count plus equal 1. This is it. And then after we do that, we also want to log or perform an event of what we have just done. And so to do that, we are going to use the log macro. It's so good that Stella made use of macros a whole lot. From what you are seeing here, you notice that this symbol short is a macro. Notice that this log is a macro. There are other macros we'll be seeing that Stella made use of a lot. So we are going to log env. And what are we logging? We're saying count and we are showing the count that we are logging. And so now we have incremented this count. And now at this point, if this was 0, at this particular line on line 18, it becomes 1. And then what happens? We are storing the 1 again. So env.storage .instance .set. So notice something. So what's the key? Notice that this thing asks me for the key and the value. What's the key? The key in this case is counter. Counter. And then what's the value? The value is basically what we are trying to store. And what are we trying to store? Count. And in this case, we can basically say we have set this particular count into the storage. So what then is the next thing to do? This brings us back to our mind when we are talking about temporary storage, permanent storage, and instant storage. So what we want to do here is to work with one type of storage. And what we are working with is a temporary storage. What does this mean? This means that we want to keep this particular count in the ledger until a certain ledger. What does that mean? That means that what we are trying to count, we are trying to keep it in the blockchain, in the Stellar blockchain, which is the ledger in, we can call it the block, but in Stellar we call it ledger. And so until certain ledger, it is then removed. So how do you do that? You say env.storage.instance, we are keeping that instance dot extend. We want to extend it, the threshold 100. We want to extend it to 100. So after the 100th ledger, what happens? Automatically, the instance, which is the storage, is removed or deleted from the Stellar ledger. So we are going to remove our to-do macro, and at this point, we will add count. So with this, we have completed our function, our increment function for count. So the next thing we'll be doing now is to create a function that can help us get our count. So we can name it get count, basically. So what would be inside the function? We have env, obviously, where we are getting access to the storage. And then we want to return the count, U32. And then it's just as simple as saying env.storage.instance.get. It's as simple as get and set. Everything we are doing is just getting and setting the data. That's how simple smart contract is. If you think of other smart contracts too, apart from Stellar Soroban smart contracts, everything is still all about getting and setting. So why do we have a problem? It said it expected U32, but found this. So where is the problem coming from? Let's say, oh, we added this at the back. Remember that if we are to add this at the back, that means we want to store it. If we had stored it like this and said count is this, then we returned count, then we won't have gotten that error. But since we do not want to do it like this and we want our code to be clean, what we then do is remove this and then ensure this is not added to the back. And at that moment, we get our code. So at this instance, we can basically say that we have completed the increment contract that we are planning to build. So before we proceed, does anyone have any questions concerning this? Anyone have any question? Okay, Mubarak.
Yeah, hi. Can you explain the under the function, under the increment function? Can you explain the last line before the count is returned?
You mean this line?
Yes, like yeah, that
Now,
extend the TLS. Yeah, what?
Good. So now in Stellar, there are different types of storages. From previous classes, I've explained that we have the temporary storage, permanent storage, and instant storage. And in this particular case, this is not a permanent storage. We are trying to say that this particular count that we're keeping on the Stellar blockchain, after the 100th ledger that we have called this function, automatically delete this particular storage. This is obviously the key to the storage, but automatically delete this count from the Stellar ledger. And at that moment, you have no access again to getting that count. So at that point, if you call this function get count, you obviously would not get it. because the function, the storage I meant, is no longer on the Stellar ledger. Does that make sense to you?
Yeah, it did. I just wanted to know why are you passing like two values? Is it like the way the function is defined, like 100, like two values in there?
The first one is the threshold, as you can see. I intentionally kept this on it so you can see it.
Okay.
Then the other one is when it is extended to. So I'm just going to read what is there for you to see what it really means, apart from what I have explained before. So it says extends the TTL to the instance and code only if the TTL for the provided contract is below the threshold ledger. The TTL will become extended to. Note that the threshold check and the TTL extensions are done for both the contract code and the contract instance. So it's possible that one is bumped, but not the other, depending on what the current TTLs are. The TTL is the number of ledgers between the current ledger and the final ledger of the data can still be accessed. Does that make sense to you?
Yes.
Great. Okay. So I guess your question then is answered. Does any other person have any question again?
Yes, I had a question, but I couldn't answer. Yeah.
But
So
what-
can you hear me?
Okay, yeah, I can hear you.
All right. Going back to the contract.
Okay.
Yeah. Is it that whenever you want to like perform any interaction with Zorobam, you must always use .env.storage?
Exactly. Why? Now I'm going to go to this env and you are going to see what is inside. What does env do? It provides you the access to the environment of the contract. So literally, everything you need concerning the contract is inside it. The env, if you notice what we are doing here, the env, we are calling the storage from the env. Can you see? env.storage. And then we are getting an instance of that storage. And then we are seeing what is inside that instance. So what we are getting here in this case is the key to the storage. And the key is just like a pointer to where this count is being kept. If you remember pointers and storage, when I explained it back when we were having the Rust class, I explained that this literally explains the difference between the stack and the heap. And in this case, if I ask you, on what side does this count as? Is it the stack or the heap?
I'm taking stack.
No.
Not a
We will say the heap. Why did we say
Why?
that? This is because we have a pointer to where the data is stored.
pointer. Okay. So the counter you declared up above. Can you hear me?
Yes, this character is literally
You
what
just
you
typed the
call
word
the
counter.
data key. Yes, you can type anything here, basically. You can type anything here. It's just we can call it the position. You can call it the position it is kept or the data key to where this data count is being stored. Does that make sense?
Kind of. But that symbol shot that you use, that function symbol shot, what does it do?
If you look at symbol is literally what helps you create a data key. So you can create a data key
Data.
with this symbol, and what this macro returns to you is this data type symbol. And so with it, you can create. So now, imagine I have, let me think of something we can use to show that, okay, you can have two different datas and you're keeping it somewhere. Let's think of, For this one, we are using a counter. Let's think of something else. Let's think of age. Let's think of age. So because of our time, I don't want to have so much implementation on this. So I'll just name this age. Are you seeing what I'm doing?
Yes.
So I'm going to create a function, and the function is basically going to do the same thing that this increment function is doing. But this time it is storing it inside this age. That is, it is using age as the data key. So I'm going to name it increment age, or let's use it here. Pop on increment age or increase age. So for that, we would have ENV, which is basically our entry point, ENV. And or let's just have it as the same thing. There's no need to add so much implementation. This one, we shouldn't be returning it. So let's say new age equals, okay, let's add the data type is a U32. And so we say it's equal to env dot storage dot instance dot get, and then what we are adding here is age, and then we say dot unwrap, or, and then we add 0. So we keep it here, and then we say new age plus 1. Plus 1. And then we don't need to log the new age. Let's just set it env dot storage. Notice that what this function is doing is the same thing as this function, but I'm just showing you that it is just a data key. It's just like the key to the storage location. So we say dot instance. Okay, dot instance dot set. So we are setting it. What are we setting? We are setting age for what's the value we are setting? The value we are setting is new age. New age. And so, yeah, we keep it. Why do we have a problem? Okay. So it's meant to be a reference, not the main thing. So let's stop at this. Let's just stop at this. So look at what we have here. What we have here, we have a new entry point to the data, to the storage location. We named it age. And so this is just what we just use to create the points where we are using as the data key, age. And so for that, I was able to use, okay, you have a question? You can unmute and speak.
Yeah, as the question I have is that, okay, when you're saying like getting a data key, it's like almost you saying like, okay, for you, if you want to interact with a specific, it's just a specific block. Let's say if you want to create a block or it has a block, just like do this env storage instance, then get stuff like that. This line is constant.
It's not always constant like that. Now, what we are doing is a very simple logic. The logic we are trying to do here is just an incremental logic. Now, there are times when you have to, perform complicated logics. But at the end of the day, one thing you know is that you have to set and get whatever you are doing, whatever logic you are doing, you have to still set it on the blockchain, and you still have to get it from the blockchain. So that's why I said at the end of the day, all you are doing is just setting and getting. So yes, storage instance would always be there because you have to store something, and then getting it would also have to be there. So that's just the point. you might always need to do this, depending on what you are writing. Now, in a situation whereby you have persistent storage, it might be different. Is that taken?
Yes.
Okay, great. So right now, the next thing we'll be doing now is to write our tests. So what do we have? Oh, we cleaned our tests. So let's just have it at the side. So for the testing, obviously, you need to have your CFG. So you have this. Give me a second. Yeah. So you have your CFG basically, and that is what you use to test. Did we even export this? Okay, yes, we did. So you have the square brackets, CFG, and then inside it, you say test. So you use super, then you use Soroban. We want to get all the things for testing. So let's say, well, one thing we want to use is the Soroban SDK, and we want to use the tests utils, and inside it we want to use logs. We want to use logs, and what else do we want to use? Obviously, the env. The env is where we are going to get our. The env is basically where we are going to get our contract storage. So we can also use an external create std, and then we write our first test. So for our first test, we have this, as we all know, that this has to be in front of the test. So we are going to create our first test and say test increment. What's the name of the function? It doesn't matter. I just want to add a test increment. See increment. So for test increments, we are going to first, what's the first thing we are going to do? We want to define our environment. And to define our environment, we have to create the env because that is basically the contract environment. So let's do that by saying let env equals env and then default. I think I can on my camera back since the network is kind of stable again. So yeah. So we'll say env and we call this defaults. So it's basically default. Then the next thing we want to do then is we want to create the contract instance. That is, we could call it the contract ID, or we could call it the contract address. But then let's just identify it as the contract ID. So in that sense, we say contract ID. We say it's equal to env dot. We want to use the register contract function. Let's just remove this from the side. Let's try to remove this. So in it, oh, you have, for this, we add none to it. And then we add incremental contract. Yes. So that's it. So this is more like the address of the contract. So now we want to interact with this contract, and to interact with it, let's create a client. So we create the client and we say, so to create the client, obviously we would use the incremental contract, and then we would add clients to the back. And then with that, we create a new one, and inside it, we would obviously have our env and the address which I made mention of, or called the contract ID, would be the second parameter. So it's going to be a reference to contract ID. Contract ID. So we've basically created is there any place you're having an error? Just to be sure, is everyone still with me? Is everyone still with me?
Yes.
Okay, great. So the next thing we do is we want to assert. It's basically just the same thing I have explained from our previous classes. We want to use assert to test. So we are going to say the client dot, now the client has the access to the increment function. I'm going to say the client dot increment, is it 1? Now, at this particular point, we call the increment. The increment at this particular point on line 15 is 0. Now, the moment this increment is called, 1 is added to it. And at this point, we are testing if you increment the storage where the key is counter by 1, it should be equal to 1 when you get it. We also want to assert again that if you increment it again, we call it increment, it should be able to get 2. Why should it get 2? This is because we already have our storage as 1. And now what we are storing in our storage, looking at our code here, we first took out our storage. At this point, the storage was 1, but then calling this increment function again, we took out our storage, which is 1, and then we increased it by 1 again. So we asserted that this at this point, it should then be 1 plus 1, which is then going to be equal to 2. So that's what we are testing. So we are going to test it now. And then one reason why I created the second test is for us to check if the storage is persistent. So it's not like after it's changed to 1, then this one becomes 1, or the 1 is only working because we are storing 1. I'm going to show a vivid example of what I mean by that. But first of all, let's cargo test. It's obviously going to take a little while because it has to run through the code, and it has to basically compile all of the code. So let's wait a little bit for it. So waiting a little bit for it. So while waiting for it, we're going to run another test. This other test is then going to cover the second function. Okay. I think I'll just off my camera because I noticed it was fluctuating a little bit. So I'll just switch it up. So this is running. So we're going to create the second test. And obviously to create the second test, we obviously need to add this to it. So what would the second test be? The second test would be, we want to test if it actually returns this age. So for that, we are literally going to do everything we have done before. So let's see. We're going to say test return, or let's see, what did we even name this one? Test get count. Okay, let's name it test get count. Test get count. So testing get count. We're going to also literally do what we have done before, which is to create the env, and that's the environmental variable giving us access to that. We call it default because we want to create a default environment. Then the next thing we are going to do then is to create the contract ID, which is going to be more like the address. Because obviously, if you want to deploy you have to get the address to what you have deployed, the address of the contract to interact with it. So we are going to say env.register, and we use the register contract. So for this, we will say none, and then for the other part, we would call it increment. We call it incremental contract, basically. So the next thing we want to do, just like we have done before, is to create the client. Basically, it's more like a repetition of what we have done here, because we are basically still doing the same thing. Okay, before we continue, our test has run for this time. And since it's the first time, it's hard to compile all of that. And we can see our test passed. So I'm going to go back and quickly do something to show that our test is actually really working. I'm going to go ahead to comment this. And then I'm going to assert something. I'm going to change from our code. I'm going to change this from plus to equal. Is everyone still following me?
Mm-hmm.
Yeah, okay, great. So I'm going to change this from plus to equal, and let's see if this test would fail. It's not going to take time now. It's passed. Why then did this test pass? That is because the function we are testing is not the one we went to remove something from. This is increase age, and we are testing increment. So let's go to the function increment. Let's remove plus. And at this point, what are we doing? We are saying that this count is not increasing by 1. Rather, whatever is in this count should just be 1. So let's test it. The test should definitely do something. Fail. It should definitely fail. Good. Why did the test fail? This is because as at this point, which is line 18, the test panicked. That is, it panicked because it's calling this function is only setting the storage to 1. It is not incrementing it. It is not incrementing it. And that's to show that our test is actually working. So if we change this, but if we comment out 2 and we run this test, it obviously would pass. Why would it pass? That is because we are saying that after calling this function, our count should be equal to 1. And that is what it is doing. So we are going to just return this back and return this back. That's to show how good or how important it is for you to write a test. So we are going to write the test for the second one. And for that, we are going to create the client, incremental contract client. And then with that, we're going to create new and add env, obviously. And then we will add the instance of the contract ID on env with the env environment. And now we have it. So I'm just going to call the client and call the increment function on the client. After doing that, I'm going to assert. I'm going to assert that the client dot get count is equal to 1. Notice that I'm not using assert here, I'm using assert equal. You can basically use anyone you like. Assert equal already ensures that this is equating to this. So I'm going to run the test, and we are going to see. Good, our test is passing. Notice that this get count is basically this function get count that we created, that we use to access our data from the chain after writing the contract. So at this point, does anyone have any question? Okay, Mubarak.
Yeah, can you explain? Sorry, there's noise in my background because of the rain. Can you explain to the client part, line 23?
Okay.
Line
Good.
29.
Okay. So let me close this. So can I explain this client? Okay, great. Now, what we are doing in this test is we are simulating the Stellar chain environment. Now, to simulate it, you have to interact with your contract that you have deployed. And so to do that, whenever you deploy a contract on the chain, the first thing you want to obviously have is the contract address, because the contract address is basically where you would be able to, is more like the entry point to your deployed contract. So we are simulating that. We simulated the environment, and simulating the environment is literally having access to the storage of the contract. And in this case, we are stimulating the environment by creating a default environment. And next, we created the contract. How did we create the contract? By using the environment, we registered the contract. And what's the contract? Is incremental contract, basically this, the incremental contract. So we registered it in our simulated environment. And after registering it, we then created a client. What is the client? The client is basically going to help us assess the method inside of this contract. So if you are coming from the Solidity knowledge, you could say or call the client as something like an interface. So that interface that allows you to connect to your contract, for you to interact with your contract, basically. But it's just a simulated environment. So it's not exactly the same, but it's that idea of saying the entry points that connect you to interacting with your contract. Does that make sense?
Yeah, you did. Second question I have is there any point where we need to, like, I saw you are giving the value for contract ID equals to none. Like, is there a case that we need to pass a particular value for contract ID?
That's because naturally, this contract is a test. We are working on a test. So you can either put the original contract address or you put none. And since it is a simple test we are doing, we are just putting none there because we don't have the contract address here. Did you get that?
Yes, thank you.
Okay, great. So if I run the test, we can see that our contract is basically working. So in a short sense, that is how to write a Soroban smart contract. It's as simple as that. But one last part we want to talk about now is deployment, but our time is fast spent. So it takes a little while to, as you can see, it took a little while to just compile these contracts before it could run the test. But we are going to try to quickly deploy before our time runs out. So to do that, the first thing, let's go to our documentation again under deploy to testnet. We had already set all our environment, obviously. We have installed the Stellar CLI. We have also configured the Stellar CLI to communicate with the Stellar testnet. We have also configured our identity to sign transactions. So we are all set up. So to deploy, the first thing you want to do is to compile your contract. What did I say? To compile your contract. So to compile your contract, here's the command to compile your contract. Where is it? Yes. So compiling your contract means you are building your contract, and building it means you then have access to what? To the WASM bytecode that will be pushed to the Stellar network. So what you are pushing is not your Rust code. Rather, it is this WASM bytecode. So I'm going to copy this, and then I'm going to paste it here. And pasting it there, I'm going to press enter. Oh, we have not compiled it yet. Sorry. Yeah, Stellar contract build. So I'm going to, so here it is building the contract. So we just wait a little bit for it to build the contract. After it builds the contract, instead of the target, we will see this WASM32 unknown. It was not there before, but the moment we clicked on this, it created the WASM32 unknown folder, and it started adding the release, and we can see it's building it inside of this. And so this is what we are going to deploy to the Stellar chain. But let's wait for it to complete the building. So once it's done building, we then see the command to basically deploy it. So Coxie, you were asking a question on the Discord on how to basically deploy it, that you had problem deploying your smart contract, right?
Yes.
Okay, so did you build it first?
I think I ran that building command because it built. Well, there's one command I copied. If you look at the documentation you showed, or the ones like Stellar, so and so stuff, in
Deploy.
that deploy a contract section, yes.
Good.
Once in Stellar, RPC, I just copied everything and I pasted it, and it just
Good.
showed me error.
If we copy this thing here and paste it, we are going to get error. Do you know why? We are going to paste it, and we are going to get error. Just wait and let's see. Did we actually get error or not? We didn't get error. Why did we not get error? Let me see. Release hello world. Okay. Okay, I can see why we didn't get error. I can see why we didn't get error. Because we actually write with what we did. Release hello world. So this was what was deployed. You understand? And we named our contract hello world. Can you see? We named our contract hello world. I thought we changed our contract name to where is it? I thought we changed our contract name to incremental contract. We didn't change it here. So for that reason, what is going to build is going to be hello world. Can you see? That's the name of the file, hello world. So for that, we have deployed our contract, and we can basically our contract. Here's the transaction hash for the deployed contract. So if we check here and we search for it, this is the transaction hash. How many minutes ago? A minute ago.
Sir,
Okay, I'm listening.
please, can I see the terminal where you ran the command? I didn't get to see past what you used for the.
So here it is. Notice that I didn't change the name, this hello world. And that's exactly why we have hello world built as the WASM. So I will explain everything that is included when you are deploying the contracts. This whole command, I'm going to explain everything to you now. So let's go back to the documentation to do the explanation. So the first line says Stellar contract deploy. That's obviously the command to deploy the contract. So the next point is --WASM. This --WASM includes the exact point where the WASM bytecode you are pushing to the Stellar chain is stored after you build your contract. Now we have built the contract. Now if you open your target, look at where is the WASM. Here it is, hello world.wasm. So that is, we are also pushing the WASM. Don't forget, since we have been having the class, we've explained that what we are doing is we are pushing the Stellar WASM bytecode after writing our contract. We are not pushing the Rust code. So the next thing is the source. Who is the source? The source is basically the address, or we say the account that is deploying this contract. So every contract starting point starts with an EOA that deploys it. And in this case, Alex is our EOA. How do we know? That's because I had already set both Alex and Ayo. If you can remember from our previous class, let me go back to this and let's see where we set the account for that. So can you see? I'm going to copy this for us to see that we have actually set Alex and Ayo. I'm not sure if it's Ayo or Ayomide we set. So can you see? This is the address of Alex. So if you say Stella Keys address, Alex, we have set it already. So let's do the same thing for Ayo. I'm not sure it is Ayo we used. Okay, yeah, it is Ayo. Can you see the address? So we can also use Ayo's account to deploy this contract. And automatically after deploying the contract, you're going to see all of this success message that says the contracts have been deployed. And then you see the transaction hash. You see the link to the transaction hash to show that the contract has been deployed. Then you can, in fact, see the contract itself, the link to the contract itself that says the contract has been deployed. And lastly, the contract address of the contract that was deployed. So I'm going to click on this, open it.
But sir,
And then,
I have a question.
okay, I'm listening.
You are deploying a contract. Don't you need like 4 sets for you to deploy the contract? Or do you already have one?
I have a contract and I have a faucet on it. So the moment you create this account, now this account I created, Stella Keys address, Alex, it has an amount of faucet in it. So how do I know this?
Okay.
So I'm going to copy this address. I'm going to go and check it. How much do I have left in it? So I'm going to paste it here and we are going to see. Can you see? We have 9,997 lumen left in it. Can you see it?
Yeah. So what happens if you run out of 4 sets?
You basically create a new account. It's so easy to create a new account. Look at Ayo. I've not used this address at all. Look at it. I'm going to paste this. I don't think I've used this address at all. It's still on 10,000 completely. You get? So
Okay.
this
No
comes
problem. I'm going
together.
to try it. Try writing some.
Okay, great. This comes to the end of our class for today. I'll stop recording. I thank
Okay.
everyone that was able to attend the class. And